right? So basic principles of electricity. So in this, I would like to cover about this charge, and before that, atom. So what do you mean by protons, electrons, neutrons, and charge? What do you mean by voltage, current, and so on? So the little things. Okay. So next is about the basic circuit elements and their sources. So you know that basically three elements exist in the globally. So that is R, L, C, resistor, inductor, and capacitor. So what are their symbols, and what is its properties? So how it behaves, and what are the characteristics, and what type of sources are available. So basically we know that voltage and current sources are there. So of course we are going to discuss on those, and AC and DC power circuits. Uh, what are the minimum basic circuits, and what are the things we need to keep in mind before analyzing the circuits or solving the circuits, or going for any application, any kind of applications. And basically how many types of systems, like single phase and three phase systems. So I'm limiting up to this since it is a bridge course, and still further many types of phase systems are there, and basic laws in electrical systems. Especially I would like to discuss in this content is Faraday's law, and Fleming's left hand rule, and right hand rule. Okay, so these are the things. So mostly I hope, if everything goes well, I can cover these two areas for today's class. So coming to the basic principles of electricity. So in this, I would like to just, so here the structure of atoms. So electron, protons, and neutrons. Of course, these are the subatomic particles of this, or the sub-elements of these atoms only. And once we are familiar about this electron, proton, and neutron, so then only we can start our discussions on charge, current, voltage, and power. So let us start with this structure of atoms. Okay. So where it comes from? So why we need to focus on these atoms and all? Since we are before we need to start about this electricity concept, we need to recall this fundamental concept, that is the atom. So what do you mean by atom? So before going for atom, so we know that we need to consider any kind of conductor, or the conducting things, or maybe even the semiconducting materials, right? Let us consider this as a material. So the material may be copper, gold, aluminum, silver. So like this, which are conducting for the electricity, right? So such kind of material we need to consider. Mostly we go for copper. We all know that. Okay. So in the copper, right? So we'll be having this structure. So this is an structure of an atom. So these are the uh, some of the elements in a matter, right? So in that material, so we can observe this these kind of things, right? So it consists of an atom. So atoms are nothing but the group of atoms create a matter there. So in atom, what is happening there? Okay, so it consists of neutrons. Just a second. Yeah. So atom consists of neutrons, protons, and electrons. So mostly we might be knowing what, if someone asks us what do you mean by current. So then this concept comes into picture. So that is flow of electrons. I hope most of you know that flow of electrons. So what about the remaining things? Why we need to study about this neutrons and protons? So from this picture indicates that here we have written positive and here we have written negative. So these are the positively charged particles, and these are the negatively charged particles, and these are no charged particles. So it doesn't have any kind of charge, whether it may be a positive or negative. So that is why it is called as a neutron. Okay. So these kind of particles, which are also called as the subatomic particles. Subatomic particles. So which are called as subatomic particles, all these three. Okay, so these are the shells, we call it as shells, this outer layer. So this will be rotating, or this will be appeared in this atom. Okay, so when this kind of atom, so this is a single shell, so this is a single shell. So like this number of shells will be there. So when this atom collide with another atom, so it creates a molecule. Okay, so when an atom collide with another atom, results in formation of molecules. Okay, so soon after, when once the electricity, or once the voltage is supplied, or once any kind of if we observe any kind of behavior, like there is a flow of electrons, then we can call it as a current is allowed in that conductor. So if we want to make, to allow the flow of electrons, okay, basically it will be in a stationary position. So once the moment has been started, so like here I have given this diagram. So here, so for this material, suppose like I consider it as a copper, for instance. So it consists of number of charged particles. So in this, I am going to highlight only the electrons. So let me tell you why. What is the reason behind that? So these are the negatively charged particles. So when it starts flowing in one particular direction, so we can call it as electron direction. Okay. So then we can say that a current exists in this conductor. And again, so here one more important thing I would like to convey, that if the current is in one particular direction, exactly opposite to that, the electron flow will be there. And that is the reason for production of heat in that element. So which is because of its resistivity. Okay, so which it is going to oppose, like for example, when we ask the students to go in a particular line, obviously some students who is going to deteriorate, or they are going to deviate, or they are going to disturb the others. In the same way, when this flow of electrons will be there, some of the electrons will oppose to follow the direction. So then, of course, that phenomenon we call it as a current. So then, because of this kind of behavior, a heat is exhibited, and that we call it as, because of the resistivity, the heat is produced, and that is a property of the resistance. So, okay. Then what about these protons and neutrons? So why we call it as only the flow of electrons as the current, and why not the flow of protons is called as the current? Why not the flow of protons is called as current? It is also accepted, but the majority charge carriers are electrons. So once again I repeat this. So a conducting material has atom, so it consists of protons, electrons, and neutrons, and the majority charge carriers are electrons. So the flow of electrons is called as a current. But of course, there exists the flow of protons as well, and these neutrons, they are no charged particles, so it doesn't. I mean, it doesn't affect on the behavior of the system or the behavior of material. Okay, and this is the complete structure of this atom, and why it is being useful for our discussion. Okay, I mean to study about the electricity. Okay, so like this, around we think, yeah, around 118 types of atoms are there. So I hope you can remember this periodical table. So like magnesium, so and copper, aluminum, like this different materials are there, so different types of behaviors will be observed. So but basically we go for copper. So 90% of our materials or the equipments manufactured by using the copper itself, so we can limit up to that. So we are not bothered about the all those properties and all. And the other thing here I have missed is that nucleus, 6 protons, 6 neutrons. What is the reason of giving this? So this complete shell consists of these 6 protons, 6 neutrons, as well as 6 electrons as well. So this is one complete, uh, one complete atom there. So like this number of atoms will be there. So these atoms collide with each other atoms and creates a molecules. Okay, so that is the fundamental thing, right? So here I have given the key points, whatever the discussions I have given. So you can just cross check with this. So an atom is a building block of matter. So used to determine the characteristics of an element. So why? Uh, just a second. Element in the sense here mostly we are preferring copper. Okay, so like this, any conducting or semi-conducting material if you consider, so this is what exactly happening there. Okay, an atom is the smallest unit of matter. Okay, so and atoms are able to interact with each other, bonding to form the complex substances called as molecules. Okay, so already this point is also discussed there. And like this, like if you consider solids, liquids and gases, so it doesn't mean that only the wires are being preferred. So when we go in detail, we might be preferring some of these kind of materials as well for conducting there, like especially for the circuit breakers and all. So there also it comes into picture. So solid, liquids and gases, there also this concept arises. And lastly is protons are positively charged, neutrons are no charged, and electrons are negatively charged. So this is the thing. And coming to protons, so these are also subatomic particles. Yeah, so this is also called as the subatomic particles. This is one of the important point there. So and as well as the neutron is also a subatomic particle and electron is also a subatomic particles. Okay. In fact, so the other important thing here I would like to highlight is that so these electrons are 1800 times smaller. So when compared with the protons there. Okay. And let us go into some other important concept, charge. Okay. So what do you mean by charge? So I think our day starts with a charge, the mobile charge, right? Okay. So current is a flow of charge. Again, I can ask you that what do you mean by flow of electrical charge, especially the negatively charged particles. Again, this comes into the picture. So the flow of electrons is nothing but a, sorry, yeah, I'm here, sorry, I'm discussing about the charge, right? So the flow of electric charge, which is also called as a current. Okay. So it is going to flow around the circuit. The amount of electric charge that moves around a circuit is dependent upon the current and the length of the time. Again, if you observe this diagram, uh, so the charge. So like for example, if you charge your mobile, so you definitely know that it takes certain time period for the charge, right? So it depends upon the power, it depends upon the ampere rating, and it depends upon the capacity. So like this, some of the properties are there. So to identify the period of charge. Okay, if suppose if you are using a basic mobile, the time required for charge of mobile is less. Suppose if you are using a 5000 mAh battery, so there will be a certain time period for charging this mobile. Okay, and suppose if you are using a 10,000 mAh, so like this. So it depends upon the capacity. So so that is different. Like if you use a battery pack, right? Suppose if you use a conductor, suppose if you are using a copper pipe. So again, if I want to discuss about the element like this property charge, okay. So what is the flow of electrons in that material? Like if you see here, so again, this is the direction of current and this is the direction of electrons. So it will be opposing. Okay, and this electron carries a charge of so 1 minus 1.602 into 10 power minus 19 coulombs. So basically these are the units for the charge, so that is the coulombs. Okay, so this value is important. I hope you can note this. Okay, so again, so why it is negative means, so because the majority charge carriers are electrons, so that is why it is negative. And the finite value for this electron flow is 1.602 into 10 power minus 19 coulombs. So if you ask me about the what is the finite value, okay, so this is the one. Okay, so that's about the basic information about the charge. And the other thing here is Q equal to I into T. So charge, basically we are going to use the letter Q. Q represents the charge, or you can use the small q. If you refer some of the standard books, they are going to use the letter small q, which represents the charge, is equal to current into time. So current in the sense, again, so let me complete this concept of current, then I'll explain you about this. Okay. So again, so what do you mean by current? So flow of electrons. So again, if you ask me, only the electrons, flow of electrons means yes, majority charge carriers in any type of elements are electrons. So that is why flow of electrons is current. Okay. So it is again. So how can we calculate the current? I mean, I think most of you are familiar about this concept of current, because if you are using an AC, so the current rating will be different. Suppose if you are using a ceiling fan, the current rating will be different. If you are using a bulb, so the current rating will be different. But all for these loads, the supplied voltage is common. Okay. So the thing is that what I would like to convey is the current depends upon the type of load we prefer. Okay. So I mean, the again, the charge required for that particular element, or we call it as a load. Okay. Which is the end, which is the end equipment. Okay. So now, so the charge again depends upon I into T. So current into time, how much time it is required to charge. Suppose since I have not started with the capacitor, so I'm not going in detail. Just for your understanding or for time being, I'll tell you that suppose this is the behavior of charge. Sawtooth waveform. It is called as a sawtooth waveform. Okay, it is not linear. So soon after, when you are powering this your mobile, immediately it is not going to charge. It takes certain time for charging as well as for discharge as well. And how the characteristics appears to be is, so this is the way. Okay, so okay, so let me cover some more details in that resistor, inductor, and capacitor, so that you will be familiar about this concept. Okay, let us come to this voltage. Okay, so what do you mean by voltage? So far I hope you know about this uh, charge, atoms, subatomic particles, electrons. So the flow of electrons, I call it as current. And how, in the same way, how can I define about the voltage? Okay, so the energy taken by the ions for their movement. So this is my personal definition. So I hope it will be easily understandable for you. So the energy taken by the ions, so that may be the, so mostly between this positive and negatively charged particles, that is the protons and electrons, the energy taken by the ions for their movement. So I can define it as a voltage. Or else the other way of expressing the definition is the difference between the potential of these two particles can be termed as a voltage, right? Okay. So let us go to the standard terms. So the total work, yeah, just a second. The total work per unit charge associated with the motion of charge between 2 points is called voltage. I repeat once again. So total work per unit charge associated with the motion of charge between 2 points. So I hope which is easy for you, or which is convenient for you to remember, you can follow that. So my definition is that, so energy taken by the ions for their movement. Okay, and the flow of electrons, or the flow of charged particles, can term it as current, and the energy taken by the ions for the movement can be termed as voltage. So this will be easy for you for remembrance, and defined by Alessandro Volta. So, and this 1 volt equal to 1 joule per coulomb. So these are the uh, yeah. So 1 joule equal to 6.24 into 10 power 18 electron volt. I hope so. You please remember this point. So 1 joule equal to 6.24 into 10 power 18 electron volt. So this is the voltage. So whether it may be 240 volts, or whether it may be 12 volts, whether it may be 765 kV, or whether it may be 1100 kV, so whatever it may be. So 1 volt equal to, sorry, 1 joule equal to 6.24 into 10 power 18 electron volt. Okay. And here also, for your having your attention towards the presentation, I will be adding some of these kind of things. so that you'll have a more focus on this presentation. So if you see this battery bulb is connected, flow of electrons. Okay, so once the circuit is closed, obviously the current will be flowing. So when the circuit is open, there will not be any current flow. Obviously, I can call it as there is no electron flow or there is no charge flow. So it will be open circuit. Okay, and if you observe this diagram of physical representation, I mean for any physical example, if we want to compare, so there are two levels of water or levels of liquids are there. So this creates a difference between these two potentials, causing a potential difference, which is also called as voltage. Okay, so just for understanding, so difference between 2 points in a circuit indicates the energy required to move the charge. Okay. Next, coming to the electric power. So I hope I no need to take much time about this electric power. So we all know, so the power equal to voltage into current, cross product of voltage and current. If I want to know about what is the electrical energy, okay, so electrical energy again it can be termed as the power into time, or else I can call it as voltage into current into time. Okay, right. Next, coming for this basic circuit elements and sources. So in this voltage source, current source, resistor, inductor, and capacitor. So before going in detail, so let me brief up you what you mean by voltage source. So basically two types of sources, out of which only the voltage source exists practically. So current source never exists, just only for theoretical analysis. We will be discussing about the current source, but practically it doesn't exist. Practically, it does not exist. The current source. Okay. So coming to voltage source. So again, so when we discuss about the AC and DC, at the time I will give in detail. So these are also called as, these two type of sources are also called as the active elements. And what about this resistor, inductor, and capacitor? So I can call it as passive elements. Okay. So all together, with the combination of these sources and circuit elements, so these are called as the circuit elements. And again, so if you want to know about the active elements, so voltage and current sources comes under the active elements. And if you want to know about the passive elements, resistor, inductor, capacitor comes under the passive elements. A combination of all these components to form a closed path can be called as a circuit. Okay, let us see in detail. Yeah. So ideal sources. So name itself indicates that ideal. So ideal in the sense what we are expecting in this circuit elements. So ideal in the sense, let me use a different color. Yeah. So what do you mean by ideal? So here it is expected that no losses, no losses in the sense obviously there will be no drops. A drop in the sense again it is a voltage drop. So system is perfect. Okay. So finite voltage is expected even though there is dynamic load changes, even though there are any changes in the system. Okay. So ideal in the sense everything is perfect, there is a finite voltage and finite frequency is expected in case of it is AC. Okay. So divide again, these ideal sources are divided into two types, voltage source and current source. Again, these things will be applicable for both the sources what I have said right now, that is no losses, no voltage drop or any finite voltage is expected, pure input is expected. In case of AC it is pure sinusoidal. In case of DC, a constant DC is expected. So that is the meaning of actual ideal sources. Okay. If you see this symbol there, so this is about the source. So if any circuit, if you want to draw any circuit, so basically we keep in mind that some source should be there, some path should be there, and the load should be there. Okay, or in in our electrical terminology, we can call it as sending end, receiving end, okay. So mostly the sending end will be the source and the receiving end will be the load and the path will be there. Okay, so and again here, whether you are using a voltage source or whether we are using any current source, so that again matters. Okay, and again if you see this, uh, if you are using an AC source, yeah, if you are using an AC source, so V cos omega t, V sin omega t. So that I will discuss at the time of AC and DC sources. Okay, so let us uh, not discuss right now. Okay, so what I would like to convey from this slide is that, so if you want to create a circuit, so these three are the mandatory things. So that is the source, a load, and the path. Okay, right. Again, right. If you want to, if you go more detail about these sources, so there exist four combinations. Of course, these are not much important, but let us know about this. Voltage dependent current source. Before that, remember that two sources are there, voltage source and current source. Again, if you go in deep or if you want to classify those, so voltage depend voltage source, current depend current source, voltage depend current source, current depend voltage source. So for easy understanding, just you remember that uh, if voltage source is there, okay, suppose I consider it as a DC. Okay. If suppose I need to discuss about the voltage, if the magnitude or this voltage is depending upon the other circuit, okay, okay, some other circuit's current value, so then it is obviously called as current dependent voltage source. In the same way, you can use it for voltage dependent current source. Okay, the current will be depending on the external circuit's voltage source. Okay, so like this. Next, coming for this resistor, inductor, and capacitor. Okay. So this is one of the very important and easy concepts. So when voltage is applied across a metallic conductor. So before that, so let me start with the symbol of the resistor. So this is the symbol of resistor. So I hope you know better than me. So these are the let I write it as plus and minus. So plus the purpose of writing this polarity is to know the direction of the current or the voltage. Okay, just to know the direction of the charge there, I'm writing the polarity. It doesn't mean that I'm giving the DC supply or it doesn't mean that I'm giving the AC supply. Okay, so just to know the direction only, I'm using this polarity. So that is a very important thing we need to remember. So this is the symbol of a resistor. So here, whenever we are going to apply a voltage across this element, the resistor. So remember again, the voltage is applied across the element and current will be flowing through the element. Okay. Always we are going to apply the voltage across any element, whether it may be a resistor, inductor, or capacitor, or any load, and the current will be flowing through the element. So these are the primary things. Okay, and again, if we apply any particular voltage for this resistor, obviously the current starts flowing through this resistor. So let us consider this circuit symbol. Okay, if I am going to apply voltage, obviously when the circuit is closed, the current will be flowing through this resistor. And here, if you observe these characteristics, so this is how the behavior of the resistor appears to be. Okay, so how it is going to respond when I'm going to apply the voltage is, it is going to respond linearly. So here, linearly in the sense, when I keep on increasing the voltage, obviously the current also rises linearly. So with respect to the voltage, so this behavior is called as the linear property or the linear behavior. And again, if you ask me that whether it lasts for a long time, like how long we apply the voltage, uh, the current will be flowing. I mean, the current will be following the voltage. No. it depends upon the temperature again. If the temperature in this element is remain constant, the behavior also remains constant. Behavior in the sense the characteristics here, behavior also remains constant. Okay. And in some other terminology, I can call it as the opposition of the flow of electrons. So resistor has the property of resistance. Resistor has the property of resistance. So what do you mean by exactly the resistance? The opposition of flow of electrons. So or yeah, the sorry opposition of yeah opposing the electron flow. Okay, which is nothing but the current. Suppose let us draw a simple example for you. Let us consider this is a small pipe. Okay, if you are just holding it somewhere, okay, this is a water flow in a pipe. Okay, just you are just holding, or you are applying, you are going to apply a small pressure in this. Okay, then there will be a small blockage, or there will be a small opposition in this area. Okay, so that kind of behavior is observed in this resistor. Okay, right. So by default, every element has particular resistivity. So how can we calculate resistivity in the sense R equal to rho L by A. So or I can call it as R equal to, just ignore this equation, R equal to rho L by A. So this is the conductivity, rho is the conductivity, and L is the length of the conductor, and A is the area of cross section. So let me write. So rho is the conductivity, L is the length, and A is the area. Okay, so based upon these three constraints or these three conditions only, so the resistivity depends. So how much it opposes. Okay, so those are the fundamental things. So of course, in the detailed class, I'm going to give some more important concepts of this resistor. Okay, and this is how the physical elements appears in as a resistor. Right. Let me see. Yeah. So this is a carbon composition, so which we call it as CC, carbon composition elements. So this is how the resistor appears to be. So earlier, before the invention of this DMM, digital multimeters, now right now we have an advanced equipments and all. We just we can place our terminals and we can calculate the resistance. Before that, they used to measure in such a way, like they used to have this color codes. Okay, so like BB Roy, I hope you can remember, right? BB Roy, great and very good wife. So such type of shortcuts they used to have. Great Britain, very good wife. So such type of abbreviations they used to have for remembering all these color codes. So black, brown, and so on. Okay. So and what are their values, multipliers, and tolerance? So I mean the variation of the value, the way because it is behaving for differently for different temperature conditions. Okay. So okay, let us keep a part of all those things. So from this, I would like to convey that. So how we are going to calculate the resistance value? Okay, these carbon composition elements. Okay, so based upon the first color, based upon the second color, and the third one. Especially these two are very important. So just this is the multiplier there. Okay, so this third color doesn't give much difference there. Okay, right. It is not much important. First two color defines what is the value of the resistance. Suppose the first one is a blue. Okay, so it is blue represents the value is 6, and the second color is red, is 2, and it is being multiplied with so here it is yellow, right? Okay, so or gold, it mostly it used to be in the gold, just like, yeah, yellow, sorry. So into so it is 1, right? So 62 6 2 ohms, and the tolerance is plus or minus 5%. Okay, so mostly it will be the gold. Yeah, here it is, the gold. Okay, so plus or minus 5% variation will be there. So this is how you are going to calculate the resistance. But right now this method is being not followed. Just we can have the resistance by using the meters and all. Right. Coming for this inductor. Okay. So how can you define inductor? A wire of certain length is twisted into a number of turns, can be called as a basic inductor. So whatever the points here I'm going to highlight, so you can go through that. So but of course, based upon my experience, I'll give you an easy tips to remember all these fundamental things. Okay, and that will not be present here. So these are the standard statements. So of course, I need to give for you. Okay, and based upon my experience, I would like to give some more tips for easy remembrance. Okay, both you can match and you can find the easiest way. Okay, you can remember the easiest points. Okay, so this is a basic inductor again. So the polarity is plus and minus were there. Okay, when you apply voltage, and obviously the current will be starts flowing through this this inductor. So this is not R. So basically the inductor will be represented with L. Okay, so from this, so if you observe these diagrams, these are the different uh, uh, types of inductors. So mostly these are appears to be like a toroid. So we no need to consider this. I hope you know better. Like most of the 90%, like I can call it as 90% today, our loads are inductive loads as per the survey. Okay, so most of the equipments are manufactured by using the copper winding. Obviously, it is representing the basic inductor. Okay, and here from this graph, so this represents the characteristics how it is going to behave. So soon after, when I apply voltage across this inductor, so let us consider it as AC supply. Okay, I'll give you later on in later classes. I'll give you the information about the AC supply. Let's just consider that AC supply is given for this inductor. So after 90 degrees, the current starts flowing through this inductor. So that is the nature of this basic inductor. Immediately the current will not be started. It takes certain time period. That is, sorry, it takes certain time to uh, start allowing the flow of current. Okay, so it is an ideal case. 90 degrees in the sense, if you ask me exactly it is 90, no. So this is an ideal case. If it is a non-ideal in the sense, it will be always so less than 90 degrees. Okay, right. So here the important point is that so a wire of certain length is twisted into a number of turns, can be called as a basic inductor, and the property of this inductor is the current will be lagging behind voltage. So soon after the voltage is applied, it takes 90 degrees time period uh, uh, for allowing the current to flow through it. Okay, so that is the basic behavior of this inductor. So that is why it is also called as the lagging loads. The other name or the other terminology for calling the inductive loads are called lagging loads. Okay, done. And coming for this capacitor, so yeah, so coming for this capacitor. So, yes. So again, a two parallel plates of equal length and equal height. Okay, so one will be the positively plates or the higher potential plate, and the other will be the negative or the lower potential plate. And in between these two, a dielectric medium, mostly maybe the air or some other materials and so on, so will be used, and I can call it as a dielectric medium. Okay, so it is being used. Okay, so that represents a basic capacitor. And what is the property of the capacitor? It stores the energy in the form of electrostatic field. I just forgot to highlight the important thing here. So inductor stores the energy in the form of electromagnetic field. So that is very important thing. I just write once again. The inductor stores the energy in the form of electromagnetic field. Okay, so which is very important thing here. Electrostatic field. Okay. Right. So you can just go through the points. So here again, capacitor C equal to Q by V, rate of change of charge with respect to the voltage applied there. Okay, so if you see that the right hand side, so capacitor symbols were there. So two plates are fixed, one plate is movable. This is the different kinds of capacitor. Right now it is not important for you. So based upon the application, so and variable capacitor, so we can create a variable capacitance there. If further, if you are interested, I can write it as xc equal to 1 by omega c. This is the value of this capacitance. Okay, and again here the value of, yes, the value of inductor is omega L. Okay. So that's all about basic elements and their behavior.